Thank you very much for being here. Thank you to Mitico/Miteco for inviting us to this very nice JanusCon second edition. Um, Today I'm going to talk about how we use Janus, mm, not only doing WebRTC, but how do we integrate it in our solution that involves interconnection with SIP networks and PSTN and so on. So let's start a bit with some shameless plug. I graduated not so a long time ago already as a telecom engineer, and I'm working with Quobis and WebRTC since 2013, mainly on the backend side of the things. Don't ask me to write any fancy website because I will fail horribly, and I will never put pineapple in the pizza. So, a very small introduction about Quobis for those who don't know. We are more or less 50 people now, quite double the size since I started working there. We are doing telco integration now with WebRTC, and there is also another line of business with strictly telco stuff. We are based in Galicia, in the northwest of Spain, and we've been working with WebRTC since 2013. Our main product related to WebRTC is the now named Quobis communication platform, after having some renames. And let's go to see what this is. Our platform is an integrated unified communications platform that does mainly have the WebRTC part, where you can have the desktop application, browser application, and also native mobile applications, both for Android and iOS. We also can deliver an SDK both in JS, in native for Android and iOS, so people can use our backend, but develop their own application, then user application. And going to the backend, we have our application, WebRTC application controller. This is the service that maintains all the user data, like contact lists, creation of meetings, and we also have an XMPP server to provide the chat service. We did our own signaling server for signaling all the WebRTC part, the calls, call transfer, hold, signaling, all pure signaling of the media and the calls. And obviously we use Janus for the SFU part. And apart from that, for doing that SIP integration, we are using other standard SIP components like Camelio and Asterisk. This is how our product looks like, with lots of boxes and lines like everyone likes to have. And we have the ingress part, the engines, and we have a lot of microservices that are mainly written in Node.js. What is our code is mainly Node.js, and we have we see on the left the QSS is our signaling server, and we have an SFU dispatcher that selects which SFU will be in charge of each of the start call requests. And we have those red boxes in the bottom is the media part of the solution. We will use, we are using an SFU wrapper that's similar in concept of what we saw in the talk of Paolo, born here, I know in Napoli, but as a result of a consultation with Mitico back in 2013, 14, I remember. And there, the wrapper is like the front end part for the Janus server, and all these red boxes that are outlined with the dashed line go together when we replicate and to escalate the media part. So we have one SFU, one Janus, the wrapper, the audio mixer, and the other one, the QSS audio mixer, is our interface to the asterisk from our signaling service. So when we replicate that, we replicate all those boxes. And then we have the connection with the SIP world. SIP proxy is Camelio, and we have the recording part that is not escalated with the other side of the things. The monitoring part over there, and more or less the other stuff is not relevant for the topic of today. So what I will present to you are the three modes of interconnection with the SIP network we are using. We named that way. These are not standard names at all. It's just the names we use to refer to them. We will explain SIP trunk, SIP register, and what we called parallel SIP. So let's start with the wires of the telephony. What I refer to when I say SIP trunk, or what we understand as SIP trunk in our product. This is the very basic integration. It's just our Camelio knows how to go to the outside, and every call that is not addressed to a WebRTC endpoint is redirected to that Camelio that is configured to probably to the PBX of the customer or another public network or not. This allows as well to do some SIP header manipulations that our customer can require or whatever. So we see here a very basic diagram that illustrates how this works. We are using in Janus the SIP plugin. So I may maybe come back to the architecture. So our SFU, our Janus, has configured the SIP plugin. So when a call enters in the system, the video room is created in the Janus, but as well we have a coverage in the asterisk that is where we have all the audio mixed and send the mixed audio to the different users. And the video is always managed by Janus, obviously. And that's why we use the SIP plugin to connect the SFU with our audio mixer that is an asterisk service. The second mode of operation we can have is what we call the SIP register. That it's basically that for each login we have in our application, each WebRTC user that logs in, we replicate or we create a register, a SIP registration on the PBX, on the customer network. So the SIP network is aware of that user on the WebRTC part. So if when a user on the SIP site wants to call that WebRTC user, we maintain what we call the SIP mapping. That is basically a list with the mapping between the WebRTC user, the SIP user, and that table contains both the that mapping and the credential on the SIP side for us to do the registration on the SIP network. This is the summary diagram. And in this case, we allow that. So we can interact WebRTC users with the SIM networks, and WebRTC calls strictly remain on the WebRTC side of the deployment. If Alice calls Bob in the WebRTC, both are WebRTC users, we don't end up on the SIM network at all. I mentioned this because on the third one, well, this is a summary, sorry, summary diagram about this scenario. We have our WebRTC users that registers to the WebRTC core, and that blue box represents that we keep track of these mappings between the username that may be Alice at domain 01, and we have the SIP extension 211, for instance. And additionally, we may have the authentication data in that mapping. So on each login, we go to our SIP proxy to reflect that registration on the SIP network. And that way we can have calls in both directions. In the previous scenario with the SIP trunk, we cannot have calls. We can have calls to the inside, but without the registration, because the SIP mapping table will be checked as well. In this case, what we do is to make aware explicitly the SIP network that user is ready for receiving calls. So when we have a call coming from the SIP network, the SIP proxy will send, when we put the call through the call in the audio mixer, our QSS audio mixer is going to receive the AMI event of that call that joined a conf bridge, and send an event to our WebRTC application controller to start the signaling to the WebRTC user and place the call. Obviously, it's always querying that mapping table to know who is the recipient of that call. And then we had once request for a customer that wanted to have WebRTC endpoints, but also wanted to keep all the SIP endpoints and logic and all the stuff they have built around their existing SIP network. So they wanted our traffic for WebRTC calls to be signaled as well on their side, so they can reuse their conference log, their billing stuff, and so on. So this is what we end up calling parallel SIP. Basically, it's a way to make the SIP network and all the applications that may be already running there of the calls between WebRTC users, apart from allowing as well the intercommunication between the SIP side and the WebRTC side. So in summary, what we do, well, the benefits are those described there, what I've been explaining now. They have already infrastructure set up, and they can control both dial plan, billing, and whatever stuff they want to do with the SIP, or they are already doing with the SIP signaling. The idea is to put all the calls, even if they are WebRTC, through the SIP network. So we always enroute the calls to the outside for us by adding a specific header on the zip packet, the network does whatever he needs to do with the packets, and at some point they will notice by the existence of that header that that packet will be directed to our Camelio, so back to our network. So when we have this packet back, we check for that header. If that header matches one we already set to an outgoing call, we match it with the WebRTC leg of the call that's ringing, and we match them and resolve which user it belongs to, and we then connect all the legs of the different calls. Here, one of the challenges that I will try to mention later was to keep track of that header, to look up which calls were in place, and to not detect an incoming call from SIP to anything that was already established or not. We have to put this logic in place to know if it was a new incoming call or that incoming invite was referring to an existing outgoing one. So I will try now to make a demo of the first scenario with the zip trunk. On the left-hand side, I have a WebRTC user logged in, and on the right-hand side, we have Twinkle, a SIP user agent. So I can call from the dial pad to a SIP extension. That's the one registered on the right, and let's cross our fingers. And I have the WebRTC call ending up on the SIP side. So I can answer, calls established, obviously no video, and I can then hang up. And similarly, I can do the call on the other side. This user here is the username number 100. So if I call to 100, I should have this ringing back. So we have the call established, and we have here the call log for this the history of the calls placed here. So the challenges we find while developing these three kinds of integrations is, from the point of view of us, the developers, having three different modes of operation is always a bit of a pain to keep the different set of tests, the different configuration you have to manage for testing and debugging and also coding. Because the three modes are in deployment, they are exclusive one with each other. You have to configure the system in one way or another. In the specific case of parallel SIP, when we were doing the test, this involves tight integration with the customer or the third-party infrastructure. So we caught some issues because the configuration on the client side was not as expected, or there were some also failures on our side because we thought it was on one way or another. And when you depend on third-party infrastructure, you have to take that into account on timings and things you have to consider. And something that is not usual when working with WebRTC is dealing with the numbering plans. People from SIP are tired of dealing with all the dial plan stuff and so on. But for people working exclusively with WebRTC, all the numbering schemes and so on is always something that you have to take into account, and they're not used to. I think I went too fast, but I'm open up for questions and whatever. Thank you.
Thank you, Marcos. So are there any questions for Marcos?
Now on the WebRTC side, it's no SIP anymore, because at some point Quobis even developed like a SIP stack, coffee SIP, and then they were losing.
We are no longer using that.
Yeah, so now it's because
it's a proprietary signaling.
Yeah, this QSS is like
your own Quobis signaling server.
Okay.
Surprisingly.
No, just to clarify, it was like could have been just another controller using still SIP, because afterward it was like JSIP, right, for a while, like Quobis using JSIP.
Yeah, I don't think I got to see that. I don't think so.
Okay. Okay. Thank you.
Any other question for Marcos? No? Okay, thank you. Then we stop for a little while. Oh, sorry. Go ahead.